Okay, 9.5 notes. We're talking about the area of sectors and arc length. So a couple new concepts. The objective is to how to find the area of a circle and the area of a sector of a circle. When you hear the word sector, what do you think of? You think about a movie, you might hear about, they have to go out and do a search of this sector or a sweep of this sector. It's a part of something. So in this case, it's going to be a part of a circle. So we're going to need two formulas, which you already know, or at least should somewhat remember. The area inside a circle is pi r squared. Okay, pi r squared. The circumference of a circle, we can use one of two formulas. 2 pi r or pi times diameter. Okay, and remember, 2 times r is the diameter. So that's why you can use either formula. It just depends on what you have. Okay, let's do some examples here. Very simple, straightforward. We're going to find the circumference and the area of each of these circles. Now, for area, remember, we definitely need pi. For circumference, we can use pi or diameter. It makes no difference. But for area, we need to have the radius. So that's going to be 5. Over here, we're cool because we have the radius. We can turn it into diameter very easily. But we definitely need the radius. So 5 and 5. So circumference is, I like to do pi times diameter if you have it. So it's going to be 3.14 times 10, which is just 31.4. Oopsie. Not square centimeters, just centimeters. All right? 31.4 centimeters, because it's just the length around the circle. The area, we're going to use pi, radius this time, is pi r squared. So 3.14 times 5 squared, which is 25. And 25 times 3.14 is 78.5 centimeters. This time it's squared because it's the area, square units. Now, number 2, hopefully you don't just dive right into the problem, because if you want to pay attention, it says leave in terms of pi. So we're not going to put in 3.14. We're not even going to hit the pi key on our calculator. We're just going to leave everything in terms of pi. So again, circumference, we have to think about this as 6. That would make 12 for the diameter. It really makes no difference how you write it, because if you write 2 pi times 6, well, that's the same thing as 12 pi. So you can write out the 2 times 6, or just go right to it by looking at it. It makes no difference. But remember, we're not doing 12 times 3.14, which is 37.68 if you type it in, but we don't want that. We want it in terms of pi. Again, area is pi, which we're going to leave, r squared. So 6 squared times our pi. And we just leave it like it is, 36 pi. We're not going to multiply by 3.14 or the pi key. If you did, it'd be 113.04. Now remember, this is inches, and this is inches squared. The circumference is just measuring the distance around the circle. It's like measuring your height. It's one measurement, one dimension. All right, sector. Thinking of the area formula, which again, might as well remind ourselves, pi r squared. The area formula is pi r squared. How would we find a portion of the whole circle? Okay? Because this right here is just part of the circle. We know how to find the area of the entire thing. If we know the radius here, we can calculate the area of the circle. But what do we do if we don't know what the whole circle? Here's what we do. We take the central angle divided by 360 times pi r squared. Okay? So whatever the measure of this angle is right here, we want that measurement divided by 360. Because think about it. The entire circle is 360 degrees. This is a part or a fraction of the circle. So it's a fraction of 360. That's where that comes from. And we're going to take that fraction times the total area. And that will give us the area of that section, or that sector. So here we go. Again, notice, leave in terms of pi. Circle that, please, on your notes. Get in the habit of looking for that. If it's there, fine. If it's not, use a decimal. Okay, so we know this is 72 degrees right here. That's our central angle. So we start off by doing our central angle divided by 360. Then we're going to multiply by pi times 10 squared, our radius squared. And literally just type in your calculator. Okay? 72 divided by 360 times 100. And what you get is 20 pi. 72 divided by 360 is 0.2. 0.2 times 10 is 2. So 0.2 times 100 is 20. So we get 20 pi. And that's it. Okay? That's all we do. Of course, that would be centimeters squared. That's all you do. You take the central angle, divide it by 360, square this number, multiply them, and if it says leave in terms of pi, just leave the pi symbol. If it wanted an answer, if it did not say that, we would just take 20 times 3.14, which would be about 60 something. All right, number 4. 6 meters is our radius. Okay, that's our radius right there. 6. Now, we're trying to find the area of this section. We don't have the angle for that section. We have the angle for this section, which is not what we need. Okay? So we need to do 360 minus 148, which is 212. Now, we're going to take 212, which is our angle, divided by 360. Times pi times 6 squared. Which I'm going to calculate for you right now because I was silly when I made my key and I based it on 148, which is just a silly mistake. So 212 divided by 360 times 36 is 21.2 pi meters squared. So, like I said, I made a mistake that probably any of you would make in here if you're going too fast. I saw a number and I just started calculating without thinking, wait a minute, that's not the shaded area. The shaded area is 360 minus that. Moving on. Okay. Find the diameter of a circle with an area of 855.3. So remember, let's go back to our original formula. Area is pi r squared. All we're going to do is work backwards because we know the area. 855.3 equals 3.14 r squared. What we don't know is the radius or the diameter. If we find the radius, we can double it and get the diameter. So, what are we trying to find? We're trying to get this letter solved for. What's attached to it? A 3.14 by multiplication. How are we going to do that? By division. And whatever we do to one side, we must do to the other. So 855.3 divided by 3.14 is 272.38. But remember, that's r squared. We don't want r squared, we want r. We want the radius. So we're going to square root both sides. And that's going to give us r equals 16.5. Which is not what the question was looking for. It wants the diameter. Don't just stop and move on. The diameter is double that, which is 33. And that's going to be millimeters. Okay? So remember, you plug in the information you're given. A lot of times we want to solve for the area. In this case, we already know the area and we're working backwards to solve for the radius, which then gives us the diameter. Moving on. The area of a circle is 201.1 square inches. So that is my area. I don't have to write the formula, you know what we're doing. 3.14 times r squared. So we're going to do the same thing we did before. We're going to divide by 3.14, which gives me r squared is equal to, what was this time? 64. It's actually 64.002. There's no point in you rounding at that point because it's so tiny. Let's just go with 64. We square root both sides. R equals 8. Can we stop? Yes, because it wants the radius. The only thing we have to do is remember to add inches. After you probably put it after the 8. Okay. Fun, fun, fun. Now, to spice things up, let's have some tricky examples. Now, I'm going to show 2 different ways to do this. Okay? The new way, using the formula we just used, and kind of a common sense, little tricky way. Since this is 90 degrees, if you think about that, 90 is a fourth of 360. So if I was finding, don't shade this in, if I was finding this whole sector, I would be finding 1/4 of my circle. So literally all I would do is find the area of the circle using the area formula and divide by 4. And that's actually what I'm going to do now as one of the methods. So the obvious way would just, let's say, find the area of the circle. Area equals 3.14 times 6 squared. But divide by 4. Okay? Visualizing that if that was all shaded in, that would be 1/4 of the circle. Now we're going to have an extra step in here, but the first step is always to find the area of this sector here. Okay? Well, that's going to be 28.26. That's one way. Now I'm going to show you both ways, and you pick what works best for you. Now, the new way is with the new formula. The central angle divided by 360 times 3.14 times pi squared. If you notice, the new way is really the same thing as the shortcut, because 90 divided by 360 is, 1/4. So really, it's not a different way of doing it, it's just a different way of looking at it. You're doing the same math, it's just how you approach it. Do you see this as 1/4 of the circle and then just divide the area by 4? Or do you just want to go with the new formula? It makes no difference. You're going to get the same answer. You're still going to get 28.26. Now the thing is, we're not doing this whole sector. We're only doing the sector right here minus the triangle. So what we have to do is take the area of the sector, which is 28.26, and take out the triangle. So we have to step back a little bit, and we have to find the area of a triangle, which is 1/2 base times height. You should know that formula by now, because a triangle is just half of a rectangle. Well, there's the other, right? 6 and 6, because it's a radius, it's got to be the same. So basically, the area of the triangle is going to be 1/2 6 times 6. Well, 6 times 6 is 36. We already know that. We've already done that. 1/2 of that is 18. So the triangle's area is 18. The sector is 28.26. So we're going to take 28.26 and take out the area of the triangle, which will leave us with 10.26 square feet. Now, I know it seems like a lot, but just think about it, it makes sense. You're finding the area of the sector, you're finding the area of the triangle, and you're removing it. All right? Okay, on to number 8. Again, we can look at this as one of two ways. We do the new way, which is, this is the diameter. Therefore, it's dividing it up into two semicircles. 1, 2. So, semicircle is half the circle, so that's 180 degrees. So the new way is 180 degrees divided by 360 times pi times the radius, which is 5 squared. Or you could just take the area, old school, which is the pi r squared, and divide it by 2. Well, if you think about it, 180 divided by 360 is 1/2. It's the same thing. So this new formula really is not that new. Okay? So 180 times 3.14 times 25 divided by 360 is 39.25. That's the area of the semicircle. Okay? Area of the semicircle. Now we need to take out the triangle. Well, if it helps to look at this triangle like so, we have a 90, it's 45, 45. The hypotenuse is 10. How do we find the length of a leg? The hypotenuse divided by radical 2. We rationalize radical 2, which gives us 10 radical 2 over 2, which cancels to 5 radical 2. That means each of these legs is 5 radical 2. Okay, each of these legs right here. Now, what's the area of a triangle? It's 1/2 base 5 radical 2 times height 5 radical 2. So this is where it gets not really tricky because we're just multiplying. It's going to be 1/2. 5 times 5 is 25. Radical 2 times radical 2 is radical 4, or simply 2. Well, you can multiply 25 by 2 and then multiply by 1/2, or just think about the fact that those cancel each other. So it's 25. The area of the triangle is 25. So we're going to subtract that and get 14.25 kilometers squared. That is the area of the two red sections, or the two shaded sections there. Okay? Red on the video, shaded in your book notes. Now I know it looks like a lot, but simply really what we did was we just found the area of the sector, in this case half the circle, and then subtracted out the area of the triangle. Okay, not too much left. So, arc length is different than the measure of the arc. Arc length is the distance of the piece of the circumference. Okay, so if we have a circle and we take out a piece, this right here, if we were thinking about a piece of pie, is the crust. This piece of crust, right there, is the arc length. So let's think about it. The total distance around a circle is the circumference, 2 pi r. So the arc length is going to be the measure of our arc, let's just call it AB, divided by 360, so very similar to what we just did, times 2 pi r. If you think about what we just did for sector area, was we took the central angle divided by 360 times the area formula, pi r squared. Now we're taking the measure of the arc, which is the same as the central angle, and divide by 360 and multiply by the circumference. So here we go. First off, we're trying to find AB. We're trying to find this piece right here. Okay? The piece across from A to B. So we need this angle right here. Well, 120 from 180 is 60. So the arc measure is 60. So we take 60 divided by 360 times 2 times pi times r, which is 7. And we multiply that out, we get 7.33. Okay? Now if you think about it, let's just see what the circumference is. We didn't have to do this in the problem, but circumference is 3.14 times the diameter, which is 14. The circumference is 49.36. So that kind of makes sense, that this piece, it would take about 7 of those pieces to make the entire thing. Let's see if that makes sense. Whoops, that shouldn't happen. Okay, so I won't be able to rotate it, but you can see it would probably be about 7 of those to make the full circle. So, AB here. We're trying to find this piece. Well, together those add up to 252. If we subtract that from 360, we get 108. So, measure of the arc, 108, divided by 360, times 2, times pi, times r, which in this case is given to us as 4. That ends up being 7.54. Again, if we wanted to find out the circumference, it would be 3.14 times 8, which is 25.12. So in other words, it would take about 3 of these to make the circle. That's about right. A little more than 3. Okay. Vertical angles, 85 degrees. Supplementary, 95. We're trying to find A to C to B. So we need to add up all 3 of these, which adds up to 275. Divided by 360 times 2 times pi times r, which is 18, given to us. When we multiply that, we get 86.35. Again, just for comparison's sake, so pi times the diameter, which in this case would be 36, would be 113.04. Which makes sense. If 86 is that huge piece across, the whole thing is 113.04, that sounds about right.